The best part about being on this team is building your own drone. So we start from all the basic components, solder them together, and eventually code it to be able to fly the way that we want it to. So races are super fun. There's 4 people in a race, and basically it's to get across the finish line first. So there's a lot of drones in the air, and for that reason we need to think about how we code our drones, because we want to make sure that the rates are right for us. So the first step when planning to build a drone is determining what the drone is going to be used for. In this case, it's racing, so they need to be very, very fast and agile. If we were to build a freestyle drone, which we'd use to capture footage, it needs to be nice and slow and deliberate. It's very important to be able to change the code between the freestyle drones and the racing drones. We do this using some coding software on our computer and fine-tuning those algorithms to improve the flight characteristics of our drones.
So the Army actually possesses a number of drones. We have about 3 main systems. We have the bigger drones, which are used to give a bigger team a larger reach for the intelligence, reconnaissance and surveillance kind of aspects. We also have the smaller drones like the Black Hornet, which is used at the small team level for more in an urban environment. So the Black Hornet is one of the most recent drones the Australian Army has acquired. Has an approximate flight time of 25 minutes and about a range of up to 2 k's, weather dependent. Its noise signature is extremely low. It can sit about 10 metres above your head and you would not know it was there.
So this drone here is what we call an X-class drone. The X stands for experimental, because we like to see how fast we can get it to go by changing the propellers, the motors, batteries. And at the moment, its current configuration, this can do 250 kilometres an hour. Drone racing is probably one of the quickest emerging or growing sports in the world. It's really, especially in Australia here, it's growing quite rapidly. Currently we've got 2 world champions here in Australia. I've got Rudy Browning, who's here in Brisbane, and we've also got Thomas Mata in Victoria, and both of those guys are really into it. And yeah, it's just growing super rapidly in the world. Yeah, so we call it our first-person view, and we actually get through these goggles here. So the camera on board the drone transmits back to the goggles that we wear, and then we actually see what the drone sees. Set up a track, fly through gates and flags and stuff like that, and see who can get around the course the quickest without, exploding their drone. Our own drones ourselves. We select the components and we solder them all together. We program them through a bunch of different applications on the computer. We actually go through that whole process as well to make sure it flies how we want it to fly.
Drone racers are STEMers. They are interested in science, technology, engineering and maths. They teach themselves how to build drones, how to code, how to solder. They teach themselves aerodynamics and electronics. And they're the kind of kids we want to have a conversation with about maybe considering joining the Australian Defence Force as a career.